Well, hello everybody. Welcome to our security session today, where we're going to be talking about encryption on IBM, specifically around the introduction of field procedures and the benefit that they bring to the encryption discussion. For those that you may not know me, my name is Robin Tatam. I'm the Director of Security Technologies here at HelpSystems. I'm also one of the IBM champions for 2020, and I have a lot of certifications from IBM on this platform, but I'm also an information security manager, so I work on the compliance and regulation side of our business as well. So it's definitely my pleasure to be able to speak to you about this important IBM security topic. It's very timely, I think, based on some of the things that we're seeing, and we want to ensure that you are best equipped to be able to make good business decisions on whether encryption is right for you. I'm going to start with just a very quick and basic introduction to the concept of encryption. I think you guys can probably all figure out kind of the gist of that, but encryption is important, and it's unique in that it's a process of hiding information, right? So the encryption function itself puts data or information into an encoded form. The sole intent of that is to protect it from unauthorized viewing or access. And what's unique about encryption is that it's actually hiding the meaning of the message, not the existence of the message. So it's in essence hiding, but it's just not readable. So steganography is the idea where we're actually taking something, we're not necessarily encoding it, but we're just putting it out of view. And that could be something where a message is embedded perhaps in an image. And this dates back centuries ago. There's examples where a slave would be taken by the Roman Empire and they would shave their heads, and that they would tattoo a message on their head and then wait for the hair to grow back and then send them out to deliver this message. There was nothing hidden about the message from the perspective of if you could get to it, you could read it, but it was just the fact that people didn't know that it was there. With encryption, we're not actually hiding that the message exists. We're just making it in a form that is unreadable. Most modern or digital encryption leverages mathematical algorithms and a secret key. So this is a highly complex topic. There's many books written on the subject, and if you are interested in mathematics, this would certainly be an area of interest for you, I'm sure. When we feed input into an encryption algorithm, it starts off with the name of plain text. That means it's human readable, and the output from that is typically called ciphertext. This message can then only be decrypted back to the plain text form using the appropriate key. Encryption is actually a subset of cryptography, and some cryptographic terminology that I think is important, at least to understand, is a cipher, which is a pair of algorithms, the encryption and decryption, that perform that encoding and decoding function. Some example ciphers are Advanced Encryption Standard, or AES, Triple DES, Blowfish, and Cas5. It's important to understand that the lifespan of these ciphers is limited. Older ciphers typically should not be used, certainly after they've been broken. And today, AES is the most popular cipher. The key is what controls the operations of the cipher algorithm. The output, or the ciphertext, is manipulated by that key, and it's something that's represented by bits and bytes. So the idea with the key is that it makes it secret. There's two types of key cryptography. Symmetric, which is where the sender and the recipient share the same key. Of course, the challenge then becomes, how does the key be exchanged without the key being compromised? This is also known oftentimes as secret key cryptology for that reason. Asymmetric key cryptology is where the key pairs are not necessarily the same. So there is a public key and a private key. The public key is used to encrypt the information, and then a private or secret key is used to decrypt that information back. And this is typically known as public key cryptology. I want to just have a quick discussion as well around data risks and trends, because the cost of a data breach is something that a lot of people keep tabs on, and it's an important metric that gives us an indication of the potential cost implications of a data breach or a security incident. The costs that are analyzed include the labor costs for admin and IT, notifications of breach to customers, public relation challenges, credit monitoring, and of course, lost business and regaining the trust of our customers and our partners. It's almost at a point where we're seeing a $4 million average per data breach, which breaks down to about $150 per lost record. This varies every year based on the types of breaches that occur. And we also have to understand that not every security incident results in a data breach. Encryption has become noticed, of course, by a lot of regulatory bodies, and a lot of them now are demanding that we put the data into an encrypted state when it's stored. The purpose for this is just the acknowledgement that at some point data is most likely going to be accessed by somebody who doesn't have a demonstrable business need. And the problem then is that if that data has been breached in that sense, we have to now go through all of our risk mitigation functions. If the data is in an encrypted form, even though it may have been accessed, as long as the encryption is strong, we know that the information has not been released in a human readable form. It is indeed possible that regulations can potentially lower notification requirements. For example, GDPR in the European Union actually gives away the idea that we have to notify regulators within 72 hours upon a breach. If the data that was breached was in an encrypted state, that clock timer actually does not begin unless there is later determination that the key or the encryption itself was somehow compromised. What's valuable to know is that the cost per record of a data breach is impacted by many different factors. And in the graphic here, I've reported on several of them. And of course, encryption is one. So what we're trying to do here is bring down the approximate cost per record breached as much as we possibly can if we're unable to utterly prevent this event from occurring. Having an incident response team trained in ways to react to the potential of a security incident is the most impactful, but encryption definitely has a major impact as well. And something even as simple as employee training on how to recognize phishing attacks, for example, or questionable emails or applications can have a very noticeable impact in a positive way on the cost of a data breach. If you're questioning what type of data should be encrypted using techniques like encryption, I've listed off top 10 things here for me, but at the end of the day, it's really anything that is considered confidential to the organization, to the employees of the organization, or to its customers or partners. Common things that we get asked about, of course, are personal identifying information like social security numbers, credit card data, bank account numbers, and payroll information. So at the end of the day, what does all of this mean for IBMI? The data risks that pertain to IBMI really fall into three primary categories. The data center itself, meaning the databases that are stored on disk within the server. These databases could be influenced by a user's ability to access a command line, SQL features, data file utility, other database tools, query, ODBC and JDBC, and client access services. These database accesses can be accessed by internal people as well as potentially external hackers, and we have to be considerate of the potential of that data being brought into the public domain. For many of us, backing up data tends to introduce another layer of risk. Backup media often is passed through several different iterations of staff or organizations before it reaches its final resting place. I had an organization that I worked with that had really good security around their data center and their server. But after they backed their system up every night, they would place those tapes in the hallway for the courier to come and collect them. But of course, anybody could have walked through that hallway and taken those tapes with them. Another area that I'm not going to focus on today comes under data transmission, where we're talking about data in flight as it moves from server to server or from network to network. This is typically internet-based, and we have to ensure that that data is protected. And again, most regulations speak to the idea that if data is going to leave the host server, then it has to be stored in a protected format as it travels. I'm going to open up a quick poll because I'm interested in whether any of you are doing encryption today. So let's ask that question. I'm going to give you three options. Yes, we're doing it via disk encryption, often known as ASP or ASP encryption. Yes, we're doing it via field level encryption, or no, we're not doing it at all. And I've let you pick multiple choices in case you are actually stacking disk encryption with field level encryption. I'll just give you a moment to finish up that poll. Looks like the majority of you, over 70%, are not currently encrypting, where we are seeing about 30% of you that are. Give you just a moment for that to stabilize out, and I'll close that poll and I'll share with you the final result. All right, we're still neck and neck with regards to the methodology for those of you that are encrypting. I'm going to go ahead and close that out now. And it looks like we have 67% of you with the final answer of no, you are not currently encrypting. 19% are doing it via disk encryption, and 17% are doing it through field level encryption. Now, disk level encryption is definitely something that is extremely popular, and part of the reason for that is the idea that doing this without any invasion in the database or the application is extremely appealing. We have to consider, however, that when we encrypt disks, that at least with IBM-I, when they're decoded, they're done so non-conditionally, meaning there's no decision-making happening as to whether the data should be encrypted or decrypted or not. Now, there's some unique things about IBM-I that we have to consider in this. First of all, it's not typical that we see IBM-I disks being stolen. I may lose my laptop or leave it on a plane or in a rental car, but IBM-I typically is a server within a data center. It's not being moved, and therefore the risk of those drives being stolen is much lower than perhaps with a Windows-based server. The data that is stored on IBM-I disk is encoded in EBCDIC format, not the more common ASCII format, making that drive a little bit harder to read from a non-IBM-I environment. And in fact, if you do have another IBM-I environment and you insert that disk, you have to turn around and reformat the drive prior to its reuse. And that process in of itself will clear the data from the drive. That's not to say that somebody who is reading bits and bytes from the actual drive itself is not able to retrieve that data, but it's definitely not something where it's plug and play into another technology environment. Lastly, data that is written to IBM-I disk is typically scattered across the drives. We have a unique benefit called single level storage, whereby the memory and the disk are just treated as one large pool in essence, and the system handles all of the process of writing that data from memory to disk under the covers, and we don't have to deal with it. That's part of the reason we don't have database administrators in an IBM-I world in the same way we do in other technology platforms. So field encryption is often a consideration for people, but before IBM-I version 7.1, it was a little bit of a scary process. You see the Redbooks publication there on the right-hand side, and a few years ago, actually many years ago now, I had the honor of working on this Redbook, so I was one of the authors of this, and I had the dubious honor of working with it at version 5, release 4, when the encryption function was largely API-based or required SQL functions. The biggest thing that we took away from this Redbook is that encryption at that time was arguably targeted more towards software providers than it was to end IBM-I shops. The reason for that is that when we did encryption, it was very, very invasive. First thing to understand is that the field structures within the files had to be altered to ensure that they were in an alphanumeric format and that the length of the field typically was extended. The other option was to write what we called a shadow file, whereby the encrypted values were linked by some type of index, and the encrypted values were stored externally to the original database. This type of DB2 field structure change alone had a significant butterfly effect on the application. Level checks occurred, meaning we had to at least recompile the programs or tell the system to ignore those level checks, or more likely, we had to go through the application and restructure many IO operations. In fact, when we were encrypting the data, meaning the outbound transaction to the disk, we had two main primary programming options. Number one was to use API calls to the encryption APIs in order to put the data into an encoded state prior to the write or the update to disk. And that required extensive program modification. It wasn't hard to make those changes, but there was a lot of them. This was very similar to when we programmed for Y2K and had to extend the date from 2-digit to 4-digit. It was not hard to do, obviously, but it was very invasive and required a lot of analysis and modification to the app. We also had another option for putting data into an encrypted state, and many software vendors touted this as a way to encrypt data non-invasively, and that was to use column triggers. A column trigger calls a program anytime that column is changed and sent to disk. This is much less invasive on the application, but anybody who's used a trigger certainly knows that performance is definitely a consideration. The other thing that software vendors tended not to advise people about is that while a trigger could be used to encrypt the data, it couldn't be used to decrypt the data, because a read trigger has a hard restriction that it cannot modify the data in its process of pulling the data back from the file. In which case, we again had to turn to those calls to APIs anytime the data had to be put in a readable format, whether that was on a display screen, whether it was on a printed report, a batch process that needed to do a calculation. And that left us also with challenges with tools like Query, because there was no way easily to decrypt that data for display in a non-application environment. There were also some restrictions about not being able to encrypt date and timestamp fields, as well as blobs. So for that reason, encryption was a good discussion, but it wasn't overly adopted. It wasn't until version IBM i7.1 that we were introduced to a feature that would be a complete game changer when it came to encryption. We call them field procedures, often referred to as FieldProcs for short, and they were released with 7.1, which was back in 2010. FieldProc is actually a support technology, meaning that it enables a programmer to write encryption type applications. It wasn't an end function. The idea with the FieldProc and some database enhancements that were introduced at that same time was that it would eliminate a lot of the invasive changes that were required prior to this. There were no longer database changes required because the database itself was able to store the alternate encoded values for the traditional fields. That meant that we didn't have to change a numeric field to be alphanumeric. We didn't have to extend the length of the field or alter the CCS ID. There is support in a field procedure for DDS described physical files or SQL defined DDL tables. So there, and we can specify multiple field procs across a file. We don't want to get too carried away, because each time a record is read, each field procedure has to then be invoked to decode the value. So we don't want to encrypt every field in a file, for example. We want to be somewhat selective based on a level of assignment of criticality to a field. So those things that should be considered highly restricted, for example, not information that would normally be in the public domain. Field encryption at 7.1 also supports multi-member physical files. So if you are using multi-member PFs, then that's not a reason not to use field encryption using FieldProcs. So this was a fantastic introduction by IBM. The database change alone was of great value, meaning that we no longer had that butterfly effect on the database. So with that initial introduction to a field procedure, let's talk about a little bit more about how to add and remove them, about some of the nuances of field procedures. When we want to add or remove them, there's actually a couple of ways to do that. We can do an SQL syntax using an alter table. We can also then alter the column and set the field procedure. So what we're actually doing here is targeting a particular file, indicating which field should have the field proc associated with it, and then defining the name of the field procedure, which is simply a high-level language program. As we add that field procedure, also known as registering it, we can't have any other locks on the file. We need an exclusive lock while that alter statement is running. You also have to have alteration authority to the object, the file object, as well as use permission to the FieldProc program. So you want to make sure that when you are assigning this field procedure that you have good authority to both of those objects in order for that alter table to complete successfully. As you alter the table and it registered that field procedure to the column, it's actually going to go through and put the column into an encrypted state, which means it's going to perform a mass encoding function on any of the fields that have been assigned that field procedure name. If you have a large file, a consideration now is that that could take some time to run, and your application users are not going to be able to perform their normal functions. So consider running that during off hours, potentially submitting it to batch. But if you're a 24/7 shop, that's a discussion that we can have in the ways to optimize that activation process. In a similar stance to adding a field procedure, you can also remove a field procedure. Again, dropping the field procedure using that alter table statement. As with encryption, adding encrypted records, decryption requires a mass decoding of those field values. So when you remove a field procedure, the operating system and the database will put all of the field values back into the human readable format. And again, that has the same time considerations and invasion considerations as when you were putting the field procedure on in the first place. The encoded value, as I said, originally had a different type potentially, certainly a different length and maybe a different CCS ID than the original field. But now that we have the new DB2 enhancement that came in 7.1, we don't have to worry about that. In fact, the operating system kind of masks any complexity around that. There's no change to the record format level identifier, meaning that if you make this type of change to your database file, you will not see a level check in a program, which you would typically see if the file was changed after the program was compiled. If you look at the file field description of a file that has a field procedure associated with one or more of its columns, you'll see that certain fields have the same attributes as they've always had. Here we see a social security number that is a packed 9-numeric field. And on the right-hand side, we see that now there's a field procedure associated with this particular field or column in the table. This is an enhancement to an existing disp FFD command that shows that this is all part of the operating system function and it's fully integrated into the database. Understanding what activities will invoke the field procedure is an important aspect of learning about FieldProcs. Any type of update or write to the database using native record level commands in RPG, for example, as write or update, will invoke the field procedure. The intent, of course, then is the field procedure will put that plain text data into its ciphertext format before it goes to the disk. The application itself is completely blind to this activity. It doesn't know and it doesn't care that the data is being put into that format as it goes to disk. If you're running an SQL insert or an update, it will invoke the field procedures, as will certain CL commands like copy file, reorganize physical file member, and start DFU. If you're using query, we may see invocation of the field procedure. For example, if you run a select statement and you indicate that you want a matching consideration, then one of the tasks of the field procedure is to put the search argument into an encrypted form and then match it against the existing records. That's extremely beneficial from a performance perspective. It's because we don't have to decrypt every record to determine if there's a match. However, if you're using greater than or less than, that is certainly a consideration, because in order to determine that the search argument is less than the database record, we have to decrypt all of those values in order to determine that. Same thing with native database activities. For example, in RPG, the set lower limit, set greater than, chain, and read equal is the chain and read equal is going to be very easy because it's always looking for an exact match based on the search argument. So we can put that search argument into an encrypted state and then just match there. Very similar on the decode events. as far as what invokes the field procedure. I won't go through all of these just in the interest of time, but you can see across the list that there certainly are many things that are happening, whether it's through native database activities or through SQL or query, that are going to invoke the field procedure in order to decode the data back to its plain text form. An important consideration you should have when encrypting data in a file is whether you are sorting by something that is sequencing the file, often known as keyed files. If we have, for example, as we have here, an employee master file that is keyed by the employee ID, we have to be cognizant that after the data has been put into an encrypted state, it will not sort in the same order as it would in a decrypted or decoded state. When we use a field procedure, we are attaching the field proc program to that column. And so one of the things that will happen as that file is read is that it can read that entire file. When we're using a read, that it's going to come in a different order. So the recommendation is that instead of that read, that you use an embedded RPG SQL statement and you do a select from the file ordering by the employee ID, which will actually then return the data in the normal anticipated sequence. You shouldn't have problems if you're using chains of read equals, again, as I mentioned, because these are field matching on the search criteria, and we can encrypt that search criteria and do an equivalent of the data record using that. Again, this encryption of the search algorithm is happening automatically at the database level. You do not have to code for that. A few other things that you should know if you're contemplating field procedures. If you are doing a create duplicate object, for example, it will duplicate the field proc assignments on the file into the new object. If you're doing a copy file to transfer data from one file to another, the copy file will always first decode the values in the from file, and then depending on whether there is a field proc on the target file, it will then re-encrypt or re-encode those values as it moves the data over. This means a copy file potentially could take significantly longer than it would have traditionally when the data was all visible. Users have to have authority to the FieldProc program. So while this is a program you don't want being modified by anybody, it is definitely something that needs to be authorized. If a user tries to access a record from a file and there's a FieldProc attached to that and they're not authorized to invoke it, they'll get a CPF 4236, which is indicating that they're not authorized to open the file member. You want to make sure that the field procedures are all backed up. They're not automatically done so. So anytime you back up a file with an associated field proc, then you want to make sure that those field procs are included in your save. If you'd like to know if there are field procs on the system, you can run a select statement as indicated on the slide here to determine which of the fields have a field proc associated with them. So it'll tell you the file name and which field within the file, and then a little bit of information about the field definition, and then the name and location of that field proc. So it's a great quick way to research what potentially should be included on your backup once you start using field procs. One of the most common discussions comes from the performance aspect of a field proc. So here's some tests that we conducted. This was performed on an IBM Power 8. It had 2 cores and in a partition with 16 gig of memory. One of the things that we learned quickly is that when you add multiple field procedures to a file, it is much more advantageous to actually assign all of the field procs at once. The difference in the top graphic between the red and the blue bar is by adding one field proc at a time versus adding them all in the same instance. And you can see, especially by the time you add that third field proc, the overhead of adding them one by one by one is significant over if you had added all 3 at the same moment. Now, this particular file had 1 million records in it. So if it gives you some idea of the number of seconds involved in encoding those those records and doing that. And part of the reason that third field proc, and even to a certain extent the second field proc, takes so much longer is that we're potentially decrypting and then re-encrypting multiple fields at once. Test 2 involved reading the encrypted data, so pulling it back into an application program. We tested an RPG SQL statement and then a traditional RPG read. And again, this was the time taken in seconds to process 1 million records within an ILE RPG program. Again, depending on the number of field procs, will show a performance implication. RPG SQL is slower on a regular read than a native RPG read operation. But when we start adding field procs, we start seeing benefits in using those RPG SQL activities because the RPG SQL can be optimized. So even if you're not familiar with using embedded SQL, it's not a difficult skill to learn. There is lots of information on the internet about embedding SQL directives into native RPG, and you definitely get some performance benefits in doing so. The more field procs, the greater the benefit. If you're sitting there contemplating writing a field procedure yourself, or you have tried this in the past, there are some things that you definitely want to consider and reasons why you may want to perhaps shy away from this as a custom solution. The APIs that IBM provides are definitely fairly complex. They require some research to implement them correctly to make sure you're processing this in the ideal form. We have to make some potential application changes if we're encrypting and decrypting data. As we said before, with field procedures, we alleviate some of these challenges, but if you're doing the basic API approach, then the database changes will of course be extremely invasive. There is possibility that encrypted data will contain special characters that may interfere with a 5250 emulator. So if you're using green screens to view the data, there can be some special characters thrown up that just look very weird to the human eye. The biggest pain point, in my opinion, however, is that the encryption function itself is not overly complicated, but custom key management solutions, in other words, the portion that controls the creation and the security of the keys, often is going to be hard to achieve regulatory compliance, right? These keys are put into database files sometimes, or they're stored in scripts, meaning that they're not adequately secured. We don't have a lot of control over who can create and manage those keys. And if there is a requirement to rotate a key, you can't really do that without decrypting and then re-encrypting all the data, which is not a popular activity on a production system. The audit trails of people decrypting and encrypting, as well as managing the keys, typically is non-existent. And the biggest problem that we have at the end of the day is that the programmers who are building these applications may know now too much about your application, and that interferes with the desire for a separation of duty, whereby the data is in a safely encrypted form and only the key holders know how to decrypt it. A viable option here is to turn to a commercial solution like Powertech Encryption. This is a tool within our full portfolio that is designed to address all of those pain points, meaning that with key management and with the encryption decryption function, there's no programming on your part. The primary benefits of using a tool like Powertech Encryption is that we get that separation of duty via a global policy setting. So all of the integrated key management is driven by policy. We can integrate with third-party external key managers. So if you're doing encryption for other platforms and you have an appliance, for example, doing your key management, we can tie in with that. We control who is allowed to manage the keys and who's allowed to encrypt and decrypt data, leveraging strong ciphers like AES 256. This means that DB2 field level encryption becomes extremely easy. The steps are basically to define which fields you wish to have in an encrypted state. There is a field registry within the software, and then the process will automatically generate the field procedure. There is an option to use a column trigger. However, most people don't do this because the field procedure approach is a better one in most instances. But it's going to generate that field procedure, and then it's going to attach it to the file. It's going to put that data into an encrypted state without you having to do any code generation at all. There's support for most field types, whether it's packed numeric, zone numeric, alphanumeric, date time, even graphic formats or binary large objects. So all of this is supported natively out of the product. And we also support encryption of IFS stream files and your backup media as well. So what I'd like to do is just show you how easy this process is to take a field that is within a file and indicate that it is indeed needing to be in an encrypted state. Now I'm skipping over the process of creating the key. Typically that's more of a one-time process. The key creation itself typically is less than a 5-minute process, but this next step is what you're going to want to do with the columns within the tables. So this is what the application looks like. If it's easier to look at this in full screen, please feel free to do so. I'm going to focus on putting a field into an encrypted state. So there's menu options here for working with our keys and working with source examples if we do want to do some coding with the APIs that we include, if you want to do things with the IFS. So there's lots of different options, but we're going to focus on the one that is definitely most commonly used, which is the field encryption menu here, which is number 4. When we go to that option, what we're going to do is work with that field encryption registry. So this is the location within the product that stores which fields need to be processed into an encrypted state. These are the list of existing fields that we have within the registry. Of course, we can position to and subset these, but what I'm going to do is actually show you if I was to add a new field to this registry, what's needed. And I accomplish that task by using the F6 key. When I press that, I'm asked for a field identifier. This is a unique identifier within the registry. Easiest way to make it unique is by naming it as a combination of the library, file, and field name. That way, of course, we can only have one of those within a file, and that makes it unique easily. We're then assigning which of the fields within the database itself we're going to be processing. Here, this happens to be a customer master file, and this CMCSNO is the customer number field. We then tell it, of course, which file and library this field is within. So in this case, it's a customer master file in my library called librbt. The field type and length is assigned again from the database itself. We're not going to manipulate that. We're just going to leave it with the same definition as exists within the database itself. Once we've added the field to the registry, we have to take the step to activate it. Anything you see in the status column that is inactive means that the field procedure is known to us, but it hasn't actually been assigned as a FieldProc in the file definition. The process of activating it will run that alter table statement indicating to the operating system that going forward, all of the activities to that field now need to be encrypted or decrypted as they go. The way we control who can access that encrypted state data is through an authorization list. So by taking option 17 here, I can indicate which users are going to be able to see the data in an unencrypted state and who can see it in a masked state. I'll talk more about masks in just a second. Now, in this case, the credit card number field within the file has its own authorization list, but that's not to say that if you want your encryption to be based on a file, for example, that multiple fields can't leverage the same authorization list. In my case, I want my credit card to have its own unique priority or authorization settings, so I've assigned unique authorization list name, and I've just based them on the field name because that makes it easy to remember. I'm also going to assign the field mask. A field mask is a way to display the data in a partial form so that perhaps it's human readable to a certain extent, but perhaps not in its complete and clear view. So what I've done here is that same credit card number field has been indicated that we want to be able to see potentially the first 2 digits of the credit card number, and the final 4 digits. So this is a way for us to see enough so that, for example, if you've ever been asked for the last 4 digits of your social security number, it's quite possible that that customer service agent only had visibility to those last 4 digits. And that's a great way to maintain integrity, but still leverage the data in some form. Because this is an alphanumeric field, we also can support different masking values. In my case, if a user is unable to see the middle digits in the credit card number, we're going to replace those digits with a pound sign or hash sign in order to flag that you're not allowed to see it. If you're not authorized, then we can also completely fill the field with asterisks, and that's a way to know that you're not able to see the data at all. Now, the 2 authorization lists are pulled up here. We have the credit card number mask on the left, and we have the credit card number full on the right. My profile on this particular system is R. Tatum, and we don't see that profile anywhere in the list. Notice that the public permissions on both lists are set to *exclude, meaning that if you're not on the list, you are not going to be able to see the data in anything but the protected state. And that's an example of my situation here. I'm not on either authorization list, so the default is that I'm not going to be allowed to see the data. In fact, if I pull that credit card number up, you're going to see that the entire credit card number field has been replaced with those not authorized characters, which were the asterisks. This is a great way for users that are not given a business reason to access the data, can still see the field, but they're not able to read the information. You'll see there's other fields displayed on this screen that are in that state as well. The social security number is blocked from me. The bank account number is visible, but the credit limit number has been replaced with all 5s. So let's go ahead and show what it looks like in a masked view. So by adding my profile to the mask authorization list, giving at least use permission, that's all I need, then I now am going to get a slightly different perspective. In this case, I'm seeing, as indicated, the first 2 digits of the credit card number field and the last 4, which allows me to at least have some discussion with this case, perhaps with my customer, as to verification of that type of information. Perhaps I'm a supervisor in the organization, and there's good reason for me to be able to see that type of data in its plain text form. Here we're looking at the other authorization list, the full authorization list. And when I add my name to this one, again, with at least *use permission, this is going to take precedence over the masked one. So when I come to my customer maintenance application, you'll see that I'm able to see the full credit card data in plain text so that I can process accordingly. This is the big and most valuable difference here between FieldProcs and disk level encryption. With disk level encryption, we can't make decisions based on who the user is. It simply decrypts the data anytime disk I/O is requested. So whether it's an RPG program, a query definition, an SQL statement, a DFU, everything is going to provide that clear text view of the data, which really flies in the face of the main intent of encrypting information. Speaking of other applications, let's say somebody writes their own RPG application or they use query. In this instance, we're going to again still see the masked or encrypted or full version based on the authorization list. How is that? Because a FieldProc is a system endorsed function. It doesn't matter how you access the database. It doesn't matter which tool you use. Those FieldProcs are associated with the database layer. They are not just external applications that have to be invoked. If you're not using a green screen, then there is a possibility that we're going to use tools like ODBC or JDBC to pull data into an Excel spreadsheet. Here we see a surveyor query of the database, and we also see a DFU, tools that many of you, I'm sure, are using. And here again, we're seeing the integrity of the database being maintained. We're not simply decrypting it because they've stepped outside of the approved application. So this database layer is the magic behind the curtain here. I mentioned that key management is included, and the pun here is always that good key management practices are the key to robust encryption. If you have weak keys or you let everybody know the key, then obviously they're going to be able to decrypt the data. So there is an assumption here. Within Powertech's key management function, we're able to build an overall policy so that we indicate how keys can be created and managed. Now, there is support for the idea that even if a user has, for example, all object special authority, which would normally allow them to access most functions, that even though they would be authorized on the authorization list in traditional IBMI context, we are actually hard checking their profile to see if they have all object. And there is a setting within the software that says that they have to be on the authorization list. They cannot gain access through their all object permission, which is really, really handy. We're able to handle the key rotation, and we manage our keys in a special key store. Now, the keys themselves are stored in a special object called a validation list. And a validation list is an operating system object. It's natively in an encrypted state. There are special APIs that have to be called in order to extract it out. So even somebody with all object can't just display the contents of this object using a command. The encryption keys can be randomly generated, or you can do them by passphrases, and you can have multiple people provide portions of that. So kind of like the old style of turning the doomsday key, and you had 2 or 3 people turning different keys at the same time, so that only one person had a portion of the key, and it would require collusion between all of them to pull that off. Same thing here. We can assign portions of the key to individuals so they only know their individual component. We do support different key hierarchy. The most common one to be discussed is what's called a data encryption key, and this is what actually handles the encryption decryption activities. But the question often comes up, well, how do you protect the encryption keys? And we do that through what's called an MEK, or a master encryption key. We can have up to 8 of those assigned to an unlimited number of data encryption keys. And then there is a special product encryption key that is designed to protect the master encryption keys as well. So there's this important hierarchy. If you're not familiar with encryption and you haven't done anything with it before, don't worry about this. It's very straightforward. Most key-based encryption functions provide different levels of keys, and of course have to provide protection for those different levels of keys as well. It's not just about database, however. We also have within Powertech Encryption the ability to protect backup tapes. So if you're sending media out of the building and you want to ensure that data is sent in an encrypted state, we can do that. It's worth mentioning that if the data is encrypted at rest in the file, and you save that file, it's still encrypted on the tape, which is not something you can say for disk encryption. If you have your disk in a fully encrypted state and you say save a library, the operating system is retrieving that information from disk, at which point it's decrypting it, and then it's sending it to media, which kind of defeats the entire purpose of encrypting things in the first place. So being able to store data in encrypted form means it automatically goes to disk. If you've chosen not to do field level encryption and you just want to encrypt the media because that's the only time it leaves your environment, then this is where the backup encryption comes in. And we have native OS commands that you can run that will not only encrypt the file or the object or the library, but it will then send it to media. Again, we support key-based protection. We also support password-based protection. And the intent here is that once the data goes to that drive, it's not an instant restoration unless you have the immediate knowledge as to how to get that data back into a readable form. And let's not forget IFS. Stream files now contain a lot of valuable data from many organizations, and we want to be able to put that data into an encrypted state as well. So there are some exit points within the operating system designed for open and close, and we leverage those. If you're doing some antivirus, you may be using those exit points already, and we can interact those two together. So the intent here again is that anytime a document is stored in the IFS or written to the IFS, it's automatically put into an encrypted state. And if you're an authorized user, we can then decrypt it upon request. And this allows us to encrypt documents from products like WebDocs so that the data is stored on disk in an encrypted state until needed. There are audit trails as well. One of the most common requests from an auditor is to show me who is using the key activities. So anytime that there is a policy setting change, anytime that there is a key officer established or removed, anytime that there is a master encryption key established, and anytime even that the key stores are created or translated can be audited. If you want to take it down to the nth degree, anytime that a data encryption key is created, changed, or deleted, and anytime the field registry is manipulated. So if a new field is added or a field is removed so that it's no longer in an encrypted state, and all of those things are auditable as well. The big thing for most people, although this is overkill for many, is that we can audit when data is encrypted or decrypted based on a key setting. So you may have a key that you've indicated that anytime that key is used for an encryption or decryption function, you want to know about it. So that is capable of being audited, but understand, of course, that can generate a significant amount of audit traffic. If you're interested in giving this a try, the Powertech Encryption product is available, as are all our products, with a 30-day free trial. We call it a proof of concept in many instances, and the difference is that with a proof of concept, we'll actually help you through the initial configuration to, in essence, speed up the process of determining that this is a good fit for you. So you're well able to take this, load it in your environment, encrypt a column or two of data, see how it works, see that it is non-invasive to your application, and what a better way to kick the tires. Most of our customers can get this up and running and be encrypting data typically in less than an hour. So a very rapid start to get things going. And you can do it on your own. You can do it just as a basic trial if you want to. There is a great manual plus help text, but oftentimes we recommend, hey, why don't we show you how to do it? We don't charge for that process, and it's just a great way to kind of expedite the process. All right. Lots of customers using this product. It's had a lot of market function and proven lifespan. So this is definitely something that has been available in the IBM market, for many years now, and we definitely invite you to take advantage of it. So one thing I always suggest to people as part of these conversations, that if you haven't ever had an audit done of your IBM server, this is a great activity to perform, because all too often we find a lot of things that are arguably not configured correctly. They're simple things to fix, and without that knowledge that they are non-compliant with either a regulatory mandate or even best practices, you're not going to know to go out there and do anything with them. So a great tool that we provide is called the security scan. I know many of you have run this before, but this is a tool that is available to you to use at zero cost. It runs against your system in about 30 to 60 seconds, and it will produce an expert review that we will accompany by a human being to go through those findings with you, and do so without that cost or obligation that most people will charge you. This is going to build out about a 10 to 12 page report. It looks, this is kind of the cover page here in this browser form, but you can PDF it up, and then you can share it with your team or your auditors, or you can use it as kind of a baseline for potential improvement later on. If you've never run one of these, or if it's been at least a year, I definitely invite you to take advantage of this. It's hugely popular, and just a great way to get some understanding of how your system is configured. All right, a couple other resources for you. The first one is the State of IBM I Security Study. This is a report that we've been publishing now for 17 years. It's unbelievable, but it has amazing amount of insight into how people are configuring their IBM I server. So look for some of the good, the bad, and the ugly of what people are doing with their system. That's available for download from the HelpSystems site, and we also record a webinar when we release that. So there is a recorded webinar for 2020 out there that you can listen to on demand as well. All right, I see a couple of questions out here. I'm going to look here, but if you do have a question, feel free to use that question panel to ask away. While you think about that, I am going to ask another poll question here. If you are interested in us running one of those security scans, let us know. That way you don't have to go out to the website and type in a bunch of personal information. We'll just reach out to you directly. If you're not quite sure, or maybe you're not the decision maker, but you have piqued your interest, just indicate no at this time, and that way we can follow up with you as well if you'd like more information. So some options there. Take advantage of that, though. It's just a great resource at your disposal. All right. All right, while you guys are answering that, let me look at the questions here in the last couple of minutes that we have. Tommy, you're asking if I suggest storing FieldProc programs in the same library as its associated data. The operating system certainly can handle that. I am typically a proponent of having the database in one library and the application programs in another, but I do acknowledge in this instance, the program is really more part of the database than it is the application. The thing you just want to make sure is that all the users have use permission to the field procedure program, where hopefully in a database library, they would not have permission to the objects. Now, I know in reality that's rarely the case, but in a perfect world, users should have the appropriate level of database permission to the files, at least give them star use permission to be able to execute the program. So I don't have strong feelings. Sometimes I like things to be segmented so that they're easier to manage and secure. In this instance, we're not trying to lock people out of the programs, so putting them in the same place is not a strong feeling for me. Reynaldo, hopefully I'm pronouncing that correctly. How would you define a WebSphere connection pool scenario where web app uses a common, and I think it's truncated here. Let me see if I can get the rest of it. Uses a common username for the JDBC connection. Okay, so this is a little bit more complicated. In this case, the WebSphere connection, if it's any PC process using a service account or a common username to connect to the system, it's going to be processed based on that profile name. So if there's a common ID, the big recommendation I always have in that scenario is make sure that that common ID is not known by anybody, as far as if there's a password or if there is other uses of that profile. This would be another scenario where exit programs are really important, because if that is a known user ID and password for that common connection, you want to make sure it's only used for the JDBC connection and only for the appropriate database library, and not used for FTP and remote command and in DDM and other interfaces. So that would certainly be a consideration. But that one's, it's a little bit more of a deep question. If that didn't answer adequately, let's chat offline, and I'd be happy to explore that further. Okay. Rosario, even if Powertech is used, there will be programming changes involved, just confirming. Well, in many instances, no, that is not the case. You do not need to make programming changes in many cases. If you want more control over the encryption decryption function, you certainly can do some APIs. We auto-generate the field procedure, but that doesn't mean that there aren't capabilities where you can write your own, and we've got samples that you then embed API calls in there. So we have APIs to our functions as well. So if you want to get really deep in the weeds and you're an advanced programmer and you want to do this more manually, you can absolutely do that. But as a general rule, the program doesn't know what the database is doing, nor does it care. So as it sends the data to in essence, the output. It doesn't know if it's sending it to memory or disk, it just writes it. The field procedure takes care of putting it into that encrypted state before it's actually written to the disk, and vice versa. When the data comes back, before the program is given the data, it's put back into its decrypted or even masked state, and that typically therefore involves no program changes. If you're searching or sorting on a field that's going to end up as encrypted, that may require some code changes. So I'm not saying never, I'm saying most of the time does not require a code change. All right. All right, well, that's all I have for questions here. If you think of anything after the fact, please don't hesitate to reach out and let me know. It's been a pleasure to talk to you about this topic, and step out to HelpSystems.com if you're interested in more information about Powertech Encryption or any of our modules, and I'll be happy to share that with you. So thanks for your time, everybody. Look forward to seeing you again soon. Take care.